Good morning, everyone. All of you, please give your attendance in the chat box. Write down your student ID. Only your student ID. Don't need to mention your name. So today, I will start the experiment 1 of the chemistry session of class. The title of the experiment 1 is Standardization of 0.1 normal sodium hydroxide solution with oxalic acid dihydrate solution. Standard oxalic acid dihydrate solution. So here are two terms. You can see that standardization and another is standard. So do you have any idea about standardization or a standard solution? What does it mean by a standard solution? So have you heard about primary standard solution and secondary standard solution? Anyone?
Yes, ma'am.
Okay. So primary standard solution is the solution which is not reactive when it is kept in an open environment, like when it is prepared, after some time it will not be changed. But secondary standard solution will be changed with the reaction with the air, in presence of air, moisture. So that's the difference. So you have to learn this very well. What is the differences between primary standard and secondary standard solution? Here, the standard solution means which concentration is known. I know the concentration because I will prepare the fixed concentration, like maybe 0.1 normal, maybe 0.001 normal. So it's known and it will not be changed. But here we will know the concentration here is given 0.1 normal, but it is not standard. That's why we need to standardize it. So we are titrating to know the standard solution or to standardize. So it's not only a titrametric process. It's a standardization based on titrametric process. So you have to know also what is the difference between difference between primary standard and difference between standardization and titration. So standardization is a process by which we standardize one chemical species by the another standard solution. which is primary standard or secondary standard. But titration is the process by which we just know the unknown concentration by known concentration. There is not mandatory, should be standard solution, primary standard or secondary standard. So I'm going to the experimental or theoretical part of the experiment. I have given you the PDF or PDF format that is based on the lab report. Actually, how to write down the lab report. I have given you the PDF file in your Google Classroom. So you will have to write down the lab report for the experiment 1. Today, I will explain the lab report or the experiment, and I will give you an experimental data after the class. Then you will follow the PDF file to write down the lab report using the data. Since you are not being able to come, the experimental part is done by us, and we will give you the data. Okay, so first of all, I will explain the theoretical part. Here, the theory means on the basis which principle we are titrating. So here, sodium hydroxide is a base and oxalic acid is an acid. So it's an acid-base titration. So you have to know how to actually on which process the acid-base titration occurs. So I think all of you are well known to this because in your previous course it was included, that means in intermediate course. So you know the theoretical knowledge, but I will just recall, that is you know the oxalic acid can release 2H plus ion and sodium hydroxide can release in aqueous solution. Okay, so it can release. So here these two will make water or neutralize each other. So that's the simple thing for acid-base titration. We'll take acid in the conical flask and we'll add the basic solution from the burette. Then gradually the acid in the conical flask will be neutralized by the base that is added from the burette, and it will make water. And after that, sometime the total amount of oxalic acid will be vanished. And for the end point, when we will understand that the end we have completely neutralized the H plus ion of the acid, that's why we'll add some indicator. So for acid-base titration, we can use several types of indicator like phenolphthalein, methyl orange, but we have to choose the perfect one or the appropriate one. So that is also the concern, which one we will select. So it depends on the strength of the acid and base. Strength means here sodium hydroxide is the strong acid and oxalic acid is the weak. Sorry, it's the strong base and it's the weak acid. So for strong base and weak acid, generally we can use the phenolphthalein indicator, because phenolphthalein can be ionized or can dissociate in a basic solution. In a basic, since it get activated in basic solution, that's why you can use in the strong base versus weak acid. But if it is if it is weak base in some experiment, then we cannot use phenolphthalein perfectly, because it will not activate it properly, because phenolphthalein is an indicator. Suppose phenolphthalein, I'm denoting is as pH. In short, phenolphthalein is a weak indicator. Okay, weak indicator, not weak indicator, it's a weak acid actually. Weak acid means which actually never dissociates itself completely. Completely dissociation is not occurred for phenolphthalein because it's an weak acid. So it will completely dissociate when the pH range is 8 to 10. I'm talking about the indicator. How to choose an indicator? It depends on the nature of the indicator and titrant and titrate. So since here we are using the strong base, we can use the indicator which can dissociate in a basic pH. Basic pH. So whenever the pH is 8 to 10, the indicator dissociates itself completely and it can show its color, because phenolphthalein is colorless in acidic media. Acidic media means when pH is less than 7, but it is colorful, that means pink color in a basic pH which is greater than 7, that means from 8 to 10. Okay, I'll go to this one later. So now I'll go to the experimental part or a procedure. The procedure is divided into two parts, phase 1 and phase 2. So what types of chemicals we are using? Sodium hydroxide, oxalic acid, and phenolphthalein. These three major chemical. And the apparatus is volumetric flask, conical flask, burette, pipette filler, and another is funnel and water glass. That's all. So we have to write down the theory, the chemicals, and the apparatus. So now procedure. Procedure is divided into two phases. Phase 1, phase 2. In phase 1, we have to prepare this solution, this standard solution. If you don't understand anything, you can ask me, I will repeat. So in phase 1, 0.1 normal oxalic acid, preparation. So can you prepare 100 ml? It is 100 ml. Okay? 100 ml of this solution preparation. So can you prepare normal solution? What is normality? Do you know this one? Have you the idea?
Yes, madam.
Okay, can you tell me how much amount of this acid solution or acid should taken for making the 100 ml of 0.1 normal solution? We have to find out the weight of which amount should we take for making 100 ml 0.1 normal. So for normality, it's about the gram equivalent weight that dissolve in per liter of solution. The number of the gram equivalent weight of the solute. Solute means that one that this species is called the solute and the water is the solvent. So that is the thing, that gram equivalent of the solute dissolve in per liter of solution. So from this equation, we have to find out the equivalent weight. How to calculate the equivalent weight? The total weight is 126 point something. So I'm not writing the total. You will do it in detail. I'm just showing you. So equivalent weight divided by equivalent number. What is the equivalent number for acid? For acid, the equivalent number is the number of H plus ion that can release. For an acid, the equivalent number is equal to the number of H plus ion that can be released by it. So the equivalent number for the acid is
2.
So it is 63. So the equivalent weight dissolved in per liter solution is equal to the 1 normal. So if I say that 1000 ml, 1 normal equal to 63 gram. Is it okay? If I want to prepare 1 normal of oxalic acid solution, then I have to take 63 gram of oxalic acid in 1000 milliliter of solution. Okay, so that's the standard formula from the definition we get. So now we can prepare this one from this equation, that we need 100 ml, 0.1 normal. So it will be 0.63 gram. Okay?
Yes, madam.
Is it okay? So that's the thing.
Ma'am, can we do this with molar solution instead of normal solution?
Yes, we can do it in molarity as well. It doesn't matter, but what is the difference between molarity and normality? Do you know that?
Molarity deals with the mole number and normality is the dissolved gram amount of the
So
solute.
we can use this the molarity here also, but here I think if we take molarity or normality, it will not be changed. The result or the total thing will be the same. But in case of another types of titration, here there are some condition is appropriate, or some condition should be followed. So that's why we use in laboratory, we generally use normality. So I'll discuss this on the next experiment if I get the class. So you can use molarity also. Okay. So now we have done with the first part of the experiment. So now I will go to the experimental of phase 2. So we have prepared the lab or a video for the phase 2, because that's the part you have to do by yourself in the laboratory, but due to this pandemic situation it's not possible, so we have ourselves prepare it in the laboratory, chemistry laboratory. So please see this and you will get some idea. Already you have the idea, I know, but in our lab generally how we perform this experiment, that is the thing. So you will get some idea that about our laboratory, how we perform this in our chemistry lab. So just wait 1 second, I'm showing you. Okay, just wait. Can you see the video or not? Just a file.
Yes, ma'am.
The video is running or not?
No, madam.
Okay.
No, ma'am.
Okay, just wait. Just wait. Okay. Hold a second. Wait. I don't know, it's not showing why. Can you see or not? Just a file.
No, ma'am.
It's not working. Why? Okay.
ম্যাম ভিডিও অন করে স্ক্রিনশট দেন।
হ্যাঁ তাই তো করেছি। আমি তো আগেও করেছি বাট এটা তো হচ্ছে না এখন। আচ্ছা আমি অন করলাম, অন করার পর শেয়ার। অপশনই আসছে না আজকে।
ম্যাডাম আসছে।
আসছে, ওকে ওকে, আমি প্রথম থেকে দিচ্ছি। ওকে, so this is the weight machine. After calculating the weight in phase 1, you have to take the weight of the chemical species, that is oxalic acid, using in watch glass. It is the weight machine here. So can you see that we have making it is 0? Okay, we have made it 0 because watch glass সেরও একটা ওয়েট আছে, তাই না? এই জন্য
ওয়াচ ক্লাস অ্যাড করলে ওয়েট কিভাবে 0 হয় ম্যাম?
না না, ওয়াচ ক্লাসের যে ওয়েট আছে ওটাকে মিনিমাইজ করে নিয়েছি আমরা ওখানে ওয়েট মেশিনে। কোনো কিছু দেওয়ার পরে 0 একটা আছে যে আমাদের কি বলে এটাকে, মানে
নিউট্রাল
ওখানে একটা অপশন আছে, হ্যাঁ নিউট্রাল অপশন আছে, ওই অপশনটা ক্লিক করলে 0-তে চলে আসে। নরমালি বাজারে যেরকম আমরা মানে কেনাকাটা করার সময় দেখো না, অনেক কিছু দিয়ে পরিমাপ করে, বাট সেটার ওয়েট তো আসে না। মানে তুমি before and after you have to make it neutralize, like an option like calibration একটা অপশন আছে এখানে ওয়েট মেশিনে, নামে একটা অপশন আছে, ওইটাতে ক্লিক করলে 0 হয়ে যায়, ক্যালিব্রেট হয়ে যায়। এখানে অবশ্য টেয়ার লেখা, টেয়ারে দিতে হয়, টেয়ারে দিলে হচ্ছে 0 হয়ে যাবে, যত বেশি ওজন হোক না কেন 0 হয়ে যাবে। তো আমি কথা বলতে বলতে ওইটাতে বলতে ভুলে গেলাম। Okay, so now you can see that here oxalic acid dihydrate solution, and it's 0.634, actually 4 for the exact calculation, because the molecular weight of oxalic acid is 126.07, maybe that's why it's 0.634. so you will just calculate like this way, whatever the molecular weight. So now we are preparing the solution using the funnel and volumetric flask. Here it is the volumetric flask. So oxalic acid solution, and we will go to the phase 2 after this preparation.
Madam, was the spoon a spatula?
Spatula, what you are saying?
The
Where is the
spoon
spoon?
we used earlier. The spoon. Is that was that a spatula?
Yes. here it is the spatula. When you are taking some sample from the box, you have to use the spatula. তুমি কি এটাই আস্ক করেছো? স্প্যাচুলা কোথায়?
Yes, madam.
এই যে স্প্যাচুলা দেখেছো?
Yes, madam. So, thank you.
এই যে স্প্যাচুলাটা, এটাই হচ্ছে স্প্যাচুলা। নরমালি আমরা যদি বলি স্পুন, এটা হচ্ছে কেমিক্যাল ফর কেমিক্যালস।
ম্যাম নরমাল স্পুন বললেই তো হয়ে যাবে না, কষ্ট করে
No, you have to say spatula, okay, not spoon. So now we're going to this phase 2. In phase 2, actually, in this burette, we have taken already the sodium hydroxide solution that will be standardized. Okay, and oxalic acid is the standard solution because freshly prepared and its concentration is known, 0.1 normal. That's why it is the standard solution. And with respect to this standard solution, we have to standardize sodium hydroxide solution that is actually prepared maybe 1 day before or long ago. But it's not the thing that we don't know the concentration. We know the concentration, what is the standard concentration, because during preparation we have prepared the concentration, the solution of sodium hydroxide. So we know the standard concentration and we will provide you the standard concentration to compare with your observation. Okay. And from that we can calculate the percent of error, মানে কতটুকু ভুল হলো বা আমাদের কাজ করতে কতটুকু এরর আসলো সেটাও আমরা কম্পেয়ার করতে পারবো। So now we are taking 10 ml of oxalic acid by using the pipette and pipette filler. After taking 10 ml of oxalic acid, you can add some water, because you can see that 10 ml, when you are taking 10 ml in a conical flask, in a large volume conical flask, then the amount is very small, so we cannot be able to find out the color perfectly, and we cannot shake it perfectly. So for that reason, you can use some water here. It will not change the concentration, it will just change the volume, but all the particles in 10 ml solution will be same before and after adding water. Okay, so don't be confused why you are it's getting diluted. So it is dilute, it will be diluted, but it will not change the number of total particle in the conical flask. So each time we will use some water for our experimental purpose, that we can shake easily and we can observe the color change easily, nothing else. Okay, we are adding some water to increase the volume so that we can shake it perfectly. Now you can see that phenolphthalein indicator is using. Okay, so now can you see that we are adding phenolphthalein, but it's not showing any color because in conical flask it is acid, so pH is less than 7. That's why phenolphthalein is not active in this solution, because phenolphthalein is also another weak acid. So acid in acid will not dissociate itself or each other. So that's why it is colorless, still colorless. But with the falling of 1 drop of the sodium hydroxide, you will see the pink color appearance, but it will disappear. It will disappear. Now it will not be stable. The color is for phenolphthalein, but it is not. It is disappearing because the solution has lots of acid solution or H plus ion. That's why. Still the pH is less than 7. This is the reason. Pink color is disappearing because it indicates that still there are lots of excess of H plus ion in the conical flask. And when we are adding the base, that means hydroxyl ion from the borate, it is getting pink color suddenly, but it disappears. And finally, whenever all the H plus ion from the conical flask will be neutralized, বাংলায় যেটা বলে প্রশমিত হয়ে যাবে, then we will get the pink color solution, because that time there is no H plus ion in the solution, only the phenolphthalein ionized phenolphthalein is present. So we know when phenolphthalein get pH media, it will be ionized and show the pink color. This is the reason that we are using this type of indicator for acid-base titration. So at the end of the titration, you have to be very careful, because if you add excess amount of hydroxyl ion from the borate, then you will get the wrong volume or incorrect volume of the sodium hydroxide. So that's the end point, and this process, from this experiment, you will just take out the volume of the sodium hydroxide from the initial and final borate reading. Initially, suppose initially the borate reading was 5, and finally you have, after the end of the titration, you have found that the borate reading is 20 milliliter. So 20 minus 5 is 15. So the total amount, the total volume that is required for the to titrate the oxalic acid is 15 milliliter. So this step will be repeat more than 1. It can be 3 times or 4 times or 5 times, because we have to take an average volume, so that we cannot say that our experiment is not correct. So we'll take the data like this 4 or 3 times, maybe 3 times or 4 times, not less than 3 times. So we'll take 3 data and we'll take the average volume of the sodium hydroxide from the 3 data. So each time, should we get the same data or different data? It's a different volume of sodium hydroxide. We are taking 10 ml every time. We are taking phenolphthalein every time. Should we find the same volume of sodium hydroxide or different?
Different.
Different. Why different? Different. Should we get the different? We are taking the same oxalic acid. So we should find out we should have the same amount of sodium hydroxide, because the number of particles for 10 ml is always same.
Ma'am, the concentration should be constant in that case, ma'am. If we change the concentration at that time, you will have to change the volume also.
So we have 0.1 normal oxalic acid, and we are taking 10 ml from this solution every time. So we should get the same, but actually we will not get the same. Maybe we will get 1 or 2 same, or 3, but third one or fourth one will be different, because maybe sometimes we cannot adjust. We make some chemical error, like we add excess amount of sodium hydroxide at the end point, or maybe you have added, you can add some extra phenolphthalein. It can also make some chemical error or visible error. We cannot find out the volume, perfect volume always, lower viscous, upper viscous. So it can happen. Several types of error can be occurred. So you have to explain if you get these types of error. In practically, if you do this one, then you have to write down this. But since it is not done by you, it is done by us. So you just you will just write down like that, that maybe it is happened, মানে এটা হয়েছিল, but মনে হয় এটা হয়েছিল, you don't know what happened actually. So you have to predict, or you have to just estimate like that. So we have completed phase 2 also. Now come to the calculation part or experimental data part. I have given you the PDF. In that PDF, you will find out the format, how to write down the experimental data and how to calculate using V1S1. So I will just explain about the mechanism of the phenolphthalein indicator, how actually it happens. So most of you become confused about this. So whenever you are adding some, suppose it's a conical plus, and you are adding some sodium hydroxide from that part. And here we have oxalic acid, dihydrate solution, 10 ml. And also we have 2 or 3 drops of phenolphthalein indicator. So phenolphthalein indicator is an weak acid, I have mentioned. So in case of weak acid, we write it in short form. H for the acid, it indicates acid having H, ion H plus, and indicator. From indicator, we use IN, HIN. It means indicator, acidic indicator. If we write down INOH, it means basic indicator, like methyl orange. So this is a short form because phenolphthalein indicator have large structure. So I will try to see share with you one thing. It's not working. Why? Okay, it's working. So, okay, it will be perfect for you. So can you see? Can you see here this one?
Yes, ma'am.
Okay.
Yes.
You see, this is the phenolphthalein indicator. Okay, and this is the equilibrium condition because it's an weak acid, so it doesn't dissociate completely. That's why it's an forward and backward is occurring simultaneously. So here you can see for forward reaction we need basic media. When it get basic media, it abstracts the proton of this part. Okay, and it becomes ionized here, and pH is greater than 7. You see here in alkaline media it is pink color, so this is the anion which is formed at the end point, and we can see the color. But how it shows its color? How does it is a question. It's pink color, but why we see the pink color? It's the question for that. What is the function of phenolphthalein? What is the mechanism of phenolphthalein for showing its color? You see this anion, and this anion can this is the charge, actually charge, and charge transfer resonance. We know about the resonance, and here some electron is you can see pi electrons here. So due to this reason, this electron can move toward in between this, or in this structure. So some structural rearrangement is occurred, and this rearrangement you can see here. After some time, it rearranges like that. It becomes like that. So that's why during this thing, when the charge transfer charge is transferred along this structure, then some energy gap is occurred, energy difference. And for this energy difference in the visible range, we can see some color. Visible range means from 400 nanometer to 800 nanometer, they can emit some wave in this range, and that's why we see the color. That is the complementary color of that wavelength. So this is the thing, this is the chemistry behind this, that how actually it can show its color in basic media. I think it's clear to you. Okay, so if we ask you,
ma'am, can you repeat that part again? A bit, ma'am.
Okay, phenolphthalein, when it get ionized, they have a negative charge on its ion, right? Like this. I'm writing here. Sorry, you cannot see it. So in presence of basic media, it create indicator minus. This is the large structure, that's why I'm not being able to draw here. So this ion is transferred in the structure, and it makes some energy gap difference from higher energy to lower energy. It will be jumped to one energy to another, and when it jump and come back to the previous energy level, then it will emit some wave. Wave means in the visible range, it will emit some energy, which is the difference between from one energy level to another. It will shift due to this charge. This charge will be shifted from one energy level to another energy level. That means from one carbon atom to another carbon atom, one benzene ring to another benzene ring. That's the thing that will get some energy gap difference, and this energy gap difference is equal to the energy that is matched with the visible range. And in the visible range, we see 7 types of color, and pink color is one of them. Okay.
No.
Then by this process, we see the colorful complex or colorful chemical species. So in this case, we have oxalic acid and phenolphthalein indicator. But when we are adding the sodium hydroxide, why does phenolphthalein don't dissociate first? Why? Why it is neutralized first and it becomes after the neutralization? Can you tell me?
Oswald's dilution law.
What does it mean? You should explain.
According to Oswald's dilution law, if any weak acid or base, they do not completely ionize, but the rate of their dissociation increases with the decrease of their concentration. That is, C is alpha is inversely proportional to C. As all of the indicators are either weak base or weak acid, that's why if they are in less concentration, they get completely ionized, and their ionization and deionization is the main process of their colors. That's why they
Okay,
move the colors.
I asked you that why both is the acid, both is weak acid, but it is reacting fast, but it is indicator is not reacting at the beginning. Why?
Actually, it is reacting, but the amount is really insignificant. That's why we cannot quite notice it.
Okay, so everybody, I think everybody get understand this part, that why and how it actually occurs, how we get the endpoint. Okay, now tell me, what is the equivalent point or neutralization point? What is the equivalent point of this titration? প্রশমন বিন্দু যদি আমরা বলি বাংলায় প্রশমন বিন্দু, and its neutralization point, or it can be equivalent point, both are the same. And there are another term is endpoint. I'm saying that endpoint is the point where we see the color change. Color change means not always colorful solution. It can be colorless. Okay, it can be also colorless. We can take pink color solution, and at the end point it can be colorless. So color change occur. Color change means it changes its color. So what is the end point one? What is the neutralization point or equivalent point? Is it same or different?
It is different, ma'am. As far as I know, it is 8 to 10 in case of a strong base, weak acid.
So please explain me separately or compare between these. It is the important question for your quiz test or for your viva, oral viva, or everything. So today I have given you lots of questions, difference between standardization, difference between titration and primary standard, secondary standard, and equivalent point, end point, and phenolphthalein, mechanism of phenolphthalein. So all this question is very, very important, and normality also. So can you tell me the difference between titration, between endpoint and neutralization point?
Ma'am, when the in the neutral point we can't get any color, but in point we get a color, and there is some extra basic compound in the solution.
Okay, so it is okay that at the end point we get the color, but why it does we don't get any color in neutralization point?
Because the pH
Because
7 at that time.
Actually, the definition is that equivalent point or neutralization point is the point where equimolecular of H plus ion and OH minus ion is present. That's the point where we get equimolecular amount of acid and base. Acid and base means H plus and OH minus. Both are the same. If you say acid and base, it's okay. If you say H plus ion and OH minus ion, that's also okay. After getting the equivalent point, immediately we get the end point. That's the thing, that it's just a fraction of second, not second. It's fraction of second we'll get the end point. So it's almost the same point, but some theoretical difference is that at the equivalent point we will not get the end point because they are same. And whenever we add another drop, little drop of hydroxyl ion, that time indicator will be activated or will dissociate and ionized, then we will get the color. Okay, so it means whenever we'll reach the pH 7, then it is the neutralization point, and after that we'll get the end point. So pH curve, can you draw the pH graph for this titration? So it's homework for you. Try to learn the pH curve for this titration, for these types of titration, like as strong as base versus weak acid. It is your homework. Don't say that I'm not discussing here, because I already discussed step by step what is the pH, what is how it is changed. So you should know. You will get this in website or in any other reference book, Essentials of Physical Chemistry. So now I will see you only the experimental. Sorry, here. Can you see this?
Yes, ma'am.
Okay. So this experiment will be repeated again and again in another theory, another chemical species. So this is almost 50% is same for other titrimetric process. Only some chemical will be different only. So you have to write down the lab report following this PDF, but only you have to change some language here. You will not write down like take 10 ml of like this not language for you. You have to write down that 10 ml of oxalic acid was taken in passive form. Most of the procedure you have to follow the passive form, because you will suppose that you are doing the experiment. Okay, and this is the instruction we are telling you, that take like 10 ml, dilute is up to. So you have to write down like 10 ml of oxalic acid was taken in a solution into a conical flask. It was diluted up to 100 ml like this. Okay, so this is the experimental table, and I will provide you the data for 1 to 4 data, and this is the calculation part. It's very easy, normal for you. But you come to this one. This is the percent of error. This standard result I will provide you. This standard result, and the result you will get from your calculation, that is the observed result, and from this you will get the error. If you get some error, then you have to explain in the discussion part that what types of error actually happening. Since you are not doing the experiment, you cannot predict the error, but you can just imagine what types of error are occurring. So you just write down that maybe it has happened, maybe it was. So you should just discuss about. And this is the key point. You have to write down the key point in your at the end of your lab report. Okay, it's very important. All the part will carry some marks, and in total you will get the marks of the lab report.
Do we need to do it in Khata, or should we do it in Microsoft Excel or something like this?
Sorry?
Do we need to do the lab report in a Khata, or do we need to, can we do just do it in Microsoft?
Lab report in a proper way, like in an A4 size paper. Okay, then you have to take the screenshot, or you have to scan it and make a PDF file, and you have to send. You have to make a front page also by cover page, that is the name, title of the experiment, the number of the experiment, your the ID number, date. Okay, all this, and then you have to write down as following the PDF file. Each point will carry some marks. Each point, theory, chemicals, apparatus, every part will carry some marks. So you have to write down following the PDF. But after writing, you have to take the PDF. That means CAM scanner. By CAM scanner, we'll take the PDF file and send to our email ID, and I will provide it today. I will give you the ID today in your Google Classroom. Everything, every required documents, I will give you in the Google Classroom. So keep eyes on your Google Classroom. Okay, thank you very much. That's all. Have you any question?
Ma'am, the cover page will contain that MIST logo as well.
You can use most of your seniors use this, so you can ask them also to give a sample of the front page or cover page, then you can use. Okay.
Okay, ma'am.
And you can prepare by yourself. I said that name of the experiment, experimented title of the experiment, experiment number, your name, your student ID, and your date of submission, date of experiment, like this one. Okay. Okay, that's all. Ma'am, could you provide the classroom code? You can ask your CR to provide you. CR, are you there?
Yes,
CR,
ma'am.
can you provide the Google Classroom code to your classmate?
Yes, Google Classroom code is already provided in the group. I will again circulate it.
Okay, so also I can provide you. So okay, you give them. No problem. I have also the class code. Okay, he's asking me, so I'm giving. No problem. Just wait. That is CSE 102. All of you are in section A or section B? In section A, right? Maybe.
We are both A and B, ma'am.
We're both, ma'am.
But most of you have joined in section A, 68 students. Anyone in section B? Join? Anyone join in section B?
Yes,
ma'am.
Yes, ma'am.
But I don't get you. That's why I have not posted anything. Why? Where are you? There is no one.
Madam,
Code, ma'am. The code for section B is not provided yet. Only Major Nozusal has provided.
Okay, all of you should join in section A for now. But after, if you declare, then you can join section B. Okay? Because some problem, because we have to take the exam in all together. If we make the two section right now, then it will be a problem for us and also for you. So to maintain actually. So now for right now, all of you please join section A. And after that, after some time, if it is required, then we'll shift to section B for the section B students. Okay. So this is the class code. Can you see who is who are actually talking for the class code?
Yes, ma'am.
Okay. So you can join right now, and other person who actually still not join, you can also join right now. So everything I will give in this classroom for section A and section B. For only this code you can just right now use. Okay. Can I close? Can I close?
Yes, ma'am.
yes, ma'am.
Okay. Have a good day. See you
Ma'am,
on the
recording
next
ki
class.
provide kora hobe na?
বুঝি নাই?
Can you please say recording, ma'am? Class recording.
Yes, yes, of course. I will give you everything in GC today, by today.
Okay.
Nothing to worry. Okay, thank you.
Assalamualaikum, ma'am.
Walaikum assalam.